What if the most terrifying weapon in science fiction wasn't impossible, just unimaginably expensive? The Death Star wasn't built to win battles. It was built to erase entire planets. And if we tried to build one today, the first obstacle wouldn't be technology. It would be money. The estimated construction cost? Around $852 quadrillion. That number is so absurd it almost loses meaning. But here's the strange part. Building it would actually be the easy phase. Keeping the Death Star alive would be a financial black hole. More than 2 million people would live on board. Soldiers, engineers, pilots, maintenance crews, retail workers, even cafeteria staff. Every single day, this artificial moon would consume staggering amounts of power, food, water, and resources. And that's when things start getting ridiculous. The electricity bill alone would reach tens of billions of dollars every day. Feeding the crew would cost millions more. Laundry, waste disposal, life support systems, transportation, repairs, it never ends. But that's not even the craziest part. The total operational cost could reach $7.8 octillion per day. Per day. That's more wealth than currently exists on Earth. So why would anyone even attempt it? Because the Death Star represents something bigger than a weapon. It represents ultimate control. A machine so powerful that entire civilizations would obey out of fear. But before firing a single laser, there's another problem nobody talks about. How do you actually build a metal sphere larger than many moons? Where would the materials come from? And what would Earth have to sacrifice to make it happen? The answer reveals a hidden cost far more terrifying than money. Because the moment construction begins, our own planet may become the first victim. To build a Death Star, you'd need unimaginable quantities of steel. At first, that sounds manageable, until you realize the amount required would dwarf every construction project in human history combined. Scientists estimate Earth contains enough iron to build millions of Death Stars. But here's the problem. That iron is buried deep inside our planet. Extracting even enough material for a single station could take over 830,000 years at current production rates. And this is where it gets weird. Even after producing the steel, you'd still have to launch it into space. Not thousands of rocket launches. Not millions. Potentially millions upon millions. Each launch releasing pollution, consuming resources, and pushing Earth's environment closer to collapse. The irony is impossible to ignore. We might destroy our own world before finishing the machine designed to destroy other worlds. But what happens next changes everything. Where do you actually assemble something this large? Low Earth orbit is far too dangerous. One mistake, one structural failure, one orbital instability, and an object larger than some moons could begin falling toward Earth. That scenario wouldn't be a disaster. It would be extinction. So construction would likely happen far beyond Earth's atmosphere, piece by piece, year after year, decade after decade, until eventually a giant artificial world emerges from the darkness. And then comes the real challenge, the superlaser. Because despite what movies show us, physics has its own opinion about planet-killing weapons. And physics is about to turn this entire idea upside down. The closer scientists get to calculating the energy requirements, the more impossible the Death Star starts to look. Or does it? Destroying an Earth-sized planet requires an almost incomprehensible amount of energy. In fact, you'd need roughly a week of the sun's total energy output just to power a single shot. Think about that. An entire star working non-stop for 7 days. For one blast. But here's the strange part. The laser itself may not be the biggest problem. The recoil is. According to Newton's third law, every action creates an equal and opposite reaction. If the Death Star unleashed enough energy to shatter a planet, the station itself could be pushed backward through space. A planet killer becoming a runaway projectile. And that's when everything changes. Because scientists have proposed something far more terrifying than giant lasers. Antimatter. Matter's mirror image twin. When matter and antimatter meet, both vanish in an explosion of pure energy. And the amount required is shockingly small. Just a tiny fraction of a planet's mass could theoretically reduce an entire world to drifting debris. No giant beam. No cinematic laser. Just annihilation. Suddenly, the Death Star stops looking like science fiction and starts looking like an engineering nightmare. But that's not even the biggest twist. A real Death Star might never be used against planets at all. Instead, its greatest purpose could be saving Earth. Imagine an extinction-level asteroid racing toward us. Days from impact. No escape. No evacuation. No second chance. A weapon powerful enough to erase worlds could vaporize that asteroid before it reaches us. The galaxy's deadliest machine becoming humanity's ultimate shield. And maybe that's the deepest mystery of all. If we ever gain the power to destroy worlds, will we use it to rule through fear? Or to protect